All right, today what we're going to do is we're going to take and we're going to learn how to write formulas for ionic compounds. This is a little bit harder than writing names because we have to actually do a little bit of thinking, a little bit of math. You're going to survive. First things first, when you learned about the periodic table, you learned about valence electrons. Valence electrons are the electrons in the outer energy level, the last level of electrons. And you learned that there's a pattern. This one, group 1, 1 valence electron. Group 2, 2 valence electrons. All the way over to here until we get to group 13, or also called group 3, 3 valence electrons. Group 4 or 14, 4 valence electrons. 5, 6, 7, 8. You see the pattern? 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is for the main groups. That's how it goes. All right. Now we also learned that in order to make a compound, we need to, we're going to reset that. So we also learned that elements are most stable when they have 8 valence electrons. That is this group here, the noble gases. Every atom is trying to get that 8 valence electrons. I guess the smaller one, helium, is 2, so not every atom, but you get my drift. So what do they do to get 8 electrons? They can either gain electrons, lose electrons, or share electrons. For ionic bonding, one atom gains electrons. That's the anion, because electrons are negative, so it becomes negative. Another atom loses electrons, and it becomes a cation, which is the positive ones. Metals are cations. Non-metals are anions. Group 1, it has 1 valence electron. To be stable, you can lose 1 valence electron. If it loses that electron, all of a sudden now its outer energy level is full, because you have to fill up an energy level before you can jump to the next one. So for 1 valence electron, it actually becomes positive 1. Group 2, 2 valence electrons. It loses both of those, it becomes positive 2. Group 3, 3 valence electrons. Loses both of those, plus 1 more, so all 3, and it becomes positive 3. Group 4, we're going to ignore, because group 4 generally makes covalent molecules. Okay? It could be a positive 4 or a negative 4, but for these purposes, we're going to ignore them. Except for down here where there are metals, but they are transition or post-transition metals, so they can have multiple charges. All right, group 5 or 15, nitrogen's group. It could lose 5 electrons and become positive 5, but what it's really going to do instead is to gain 3 electrons and become negative 3. So these ones are negative 3. Oxygen's group could lose 6, easier to gain 2. So it's going to gain 2, become negative 2. Remember, gaining means it gets a negative, so if you get something negative, you're becoming negative. Group 7 or 17, the halogens, they can gain 1 electron, become negative 1. Now you can see this pattern, plus 1, plus 2, plus 3, skip it, minus 3, minus 2, minus 1. That's the pattern for the charges, okay? Now we go to the polyatomic ions. You remember these? Polyatomic ions. You can see that some of them, like right here, ammonium, positive 1. Acetate, negative 1. Hydroxide, negative 1. Nitrate, negative 1. Carbonate, negative 2. A little different. Sulfate, negative 2. Phosphate, negative 3. Lots of negatives on that one. But since those are the important ones, we'll just look at those. You need to use the charges in order to get these compounds to work. So we're going to go from there. Okay. Okay, let's do this. Lithium oxide. Lithium oxide. Okay, step 1. Write the cation symbol with charge. So writing the symbol for the cation with the charge. Lithium, Li. It is in group 1, so it's positive 1. So we're going to put Li plus 1 there. Step 2, write the anion symbol with the charge. Oxygen is oxide. Go over here. Oxygen's group is in group 6, -2. So we're going to go like this. All right, like this. Step 3, make the charges add up to 0. By multiplying. Here's what I mean. The charges have to add up to 0, otherwise things would get stuck to you all the time because there'd be extra positives and negatives in the universe. There aren't. So what you're going to do is you're going to take and look at which one's smaller. Lithium's smaller. Okay? Oxygen's bigger. So what do we multiply lithium by to make it the same as oxygen so that they add up? Because right now we have 1 plus -2. That gives us a -1. That's no good. We don't want -1. We want 0. So what do? We take and multiply this 1 by 2. Now we've got 2 plus -2. That gives us 0. So we multiply by that number. So then we write the number you multiply by as a subscript. So here's what we do. We multiply the Li by 2, so we put Li 2O. Okay, because we didn't multiply the oxygen by anything. So we ignore it. Li2O. So what we did was we took it and we multiplied the lithium by 2 so that it balanced out with the oxygen, which is -2. Because right now lithium has 1 valence electron. Oxygen has, do you remember doing this? Remember doing Li has 1 dot, 1 Lewis structure dot. O has 6 of them. If you give 1 to oxygen, the oxygen then only has 7 of them. The oxygen has, sorry, I don't like how that looks. If you give 1 to oxygen, it has 7 of them, right? Because now it looks like this. 2, 4, 6, 7. Okay, so you need a second lithium to give oxygen another one. So then oxygen becomes 2, 4, 6, 8. It has 8 valence electrons and it is content. And now it is a -2 because you gave it 2 electrons. Each of these lithiums is a +1. So we have Li2 because there are 2 lithiums. O because there's 1 oxygen. Let's do some practice. Let's go sodium nitrate. Let's do barium phosphide. Let's do magnesium sulfide. And let's do potassium sulfate. First one, sodium, Na, with a +1 charge. Nitrate, it ends in ATE, so that means we are going to have to look at our polyatomic ions chart. And we look at our polyatomic ions chart, and NO3 is nitrate, and it's a -1. So we're going to write NO3, -1. All right, we've done step 1, cation symbol with charge. Step 2, anion symbol with charge. Step 3, make charges add up to 0 by multiplying. Well, 1 minus 1 is 0. We don't need to do anything. So then we just write it as it is. Na, NO3, done. Barium phosphide. Barium. We look it up. Barium is positive 2. If you don't believe me, I don't know why you're watching this, but barium's right here in group 2, so it's positive 2. Phosphide ends in IDE, so it's phosphorus. Phosphorus is in the negative 3 group. So we write Ba plus 3 plus 2, P negative 3. Well, crap. 2 cannot turn into 3. 3 cannot turn into 2. What do we need to do? We need to find a number for each of them to be multiplied by in order to get us to 0. So we say, what is the least common multiple of these two numbers? 2 and 3. Well, the least common multiple would be 6, because 2 times 3 gives you 6. So we say 2 times 3. So barium gets multiplied by 3. Phosphide gets multiplied by 2. Now we've got 6 positives and 6 negatives, which gives us 0. Barium, Ba has a 3, so we put a 3. P, phosphide, has a 2, so we put a 2. Done. Barium phosphide. Next one, magnesium sulfide. Magnesium, we go look it up. It is Mg, and it's a positive 2 charge. If you don't believe me, we can look at it. Magnesium, right here, positive 2 group. Sulfide. Sulfide is sulfur. It's in the group 6, the negative 2 group. So we're going to put positive 2, sulfide, S, negative 2. 2 minus 2 gives you 0. We're done. Just put them together. MgS. There's our answer. Magnesium sulfide. Last one. Potassium sulfate. Potassium. K. That sounds stupid, right? But it is. Potassium. K. Plus 1. Okay? Comes from a Egyptian word. Nope. Comes from a Greek word. K. Potassium. Positive 1 charge. Sulfate. See how it ends in ATE? If it ends in ATE, it is a polyatomic ion. So we go over here. Sulfate. Right there. Sulfate has a negative 2 charge. So we get this SO4 with a negative 2 charge. Okay. The K has to be multiplied by 2. This one, all good. So this becomes K2SO4. Done. Oh, but now you're going to hate me. Watch this. Let's do magnesium nitrate. Okay, already did magnesium. It was Mg with a positive 2. Already did nitrate. NO3 with a negative 1. Well, looking at this, we've got positive 2, negative 1. So we're going to have to multiply this by 2. Oh, man, this is where you're going to hate it. So the magnesium is fine, Mg, but this one gets multiplied by 2. So we go NO3, 2. That doesn't look right because it looks like NO32. So what you have to do is you have to put a parentheses around it. So step 6, if there is a subscript on a polyatomic ion to balance the charges, put parentheses around it. So only when there is a subscript on the NO3, okay, or SO4 or OH or NH4 or CO3 or PO4, any of the ones that we talked about, okay, or the CH3COOH or COO, excuse me, then is when you need the parentheses. Okay, you did a good job. Make sure you write this stuff down.